Amazing. So thank you very much for the two former speakers. I guess it's been set up well for me, purely by accident, because I didn't contribute the subject of my talk beforehand. So apologies again for that. But to sort of pick up where May left off, I'm going to start thinking about what the structure of contracts are to a certain extent. We've done a little bit of work in the construction sector, although the case studies that I've got that we can show sort of publicly in detail are actually mostly in real estate. But I sort of thought I'd start, depending on how technical or not technical the audience is, with something I sort of throw around at the management team at Mishcon's, telling them that all the words that they hear, they've heard before, and that most of these things have been invented a long time ago. So this is my sort of potted history of legal technologies. And on the left-hand side, you've got something called the bulla, which came about in the agricultural revolution for sort of setting the agreements between counterparties, and the temper evidence seal, or tamper evident token in this case, was a sort of fired clay ball with the marks of the counterparties on it. And then obviously we get to written contracts, still a few thousand years ago, and probably the two technologies on the right hand side are probably less well known. At least you're less likely to see them in a museum. But one is a tally stick, which is where half of a tally stick is where we get the word stock or stock market from, which is the sort of advent of a distributed ledger, i.e. a distributed recording of who owes what to who. And then proof of work, the last one is a chirograph, this sort of Middle Ages England, where it's a kind of mix between a cryptographic seal and proof of work. So you would tear along the contract and you'd be able to prove that your part of the ledger tallied with other parts of the ledger by comparing the physical work of the tear. So, aspects of these systems that we're building at the moment have their roots in all sorts of things that we have used for instantiating legal systems before, and it's just a question of figuring out how they might diffuse into the economy. And I had a colleague of mine, Niall Roach, was running the workshop yesterday on coding smart contracts, and one of the questions was, should lawyers program? So I thought I'd sort of put this up at the beginning, which is, depending on what you mean by program, most computer scientists don't program, right? Most of them don't go near an assembly language or machine code at all. And so most people are in some way, at some level of abstraction, dealing with complex systems, and law is no different. And you might be using Word, but you're essentially building on an abstraction above an existing computer. So we're already using lots and lots of smart things in a kind of late 20th century economy. And this is a sort of natural evolution about what properties of the system in a 21st century economy might look like. So, to kick that off, I like this slide by Meng Wong, slightly facetiously, but over the last 50, 60 years, we've created an awful lot of technology to help write certain types of documents that we call computer programs. And on the right-hand side, we have the late 20th century contributions to legal technologies, which largely amount to a word processor. And so, again, this is not quite true, but, to motivate thinking about how we might be able to build better parts of a legal system, there's a lot on the left-hand side that can motivate us in trying to, put something in place that has advantages over where we are now. And again, just to sort of set up some of the case studies, this it's often called Web 3.0 or something, but you've got essentially three layers of the technology. The plumbing of the internet and sort of TCP/IP meant that we could connect to separate locations. And in the World Wide Web and the kind of HTTP protocol means that we can find the where stuff is stored at those different locations. And the advent of the thing that we're referring to as DLT or blockchain is really lots of different varieties of protocols that could sit on top of the internet. So yes, they could sit on top of the web, or they could sit on top of the internet, but they're just how do we link and share and move information around. And they could be fully public, and I won't go into the details of that, what that means, but from the perspective of seeing it diffuse into an economy, there are lots and lots of private applications. So can you come up with private protocols for sharing information between companies, for example? Yes, obviously you can. There's lots and lots of systems out there doing everything from accounting to supply chain management. And the question is whether the properties of these DLT systems provide some sort of additional support for the things that we're trying to achieve with those systems. So I was going to start with a case study we did with the Land Registry last year. And some of the stuff that I'm going to talk about is written up in various kind of white papers or discussion papers. So this one is available online with some of the details in it. Some of the diagrams I'm about to show you are at a resolution that won't transfer necessarily on the presentation slides, but if it's of interest to you, you can go down and have a look at the originals. So the first thing to say is that, construction and real estate, the asset life cycle is very involved. Lots of counterparties, lots of different stages, lots of different decisions. And one of the advantages, potentially, or the promise of DLT type technologies is to try and get a handle on assets with very long life cycles or assets with lots and lots of counterparties interacting in different ways. And so here we're just looking just at the real estate life cycle. And in the real estate life cycle, we've just pulled off one, essentially one little piece of it, which is buying and selling. And you can start to see the user journey at the bottom, just in terms of different counterparties. So this is a vanilla residential conveyancing transaction in the UK, where we haven't worried about all of the different things that can go wrong. This is essentially what happens if it goes perfectly from start to finish first time. And even on the sort of perfect journey in terms of arranging a contractual arrangement between buyer and seller, you can see that there are an awful lot of different stages. So if we're thinking about contracting systems, this sort of first word of warning is that the incumbent systems are very complicated. And the reason they're very complicated is they've been built up on precedent to try and give assurances and mitigate risks for both parties. But they aren't simple to build, potentially, and they aren't simple to replace in terms of the incumbent systems, going back to Richard's point about whether we do transformation or evolution. So if we look at this one in a little bit more detail, this is not only looking at the counterparties, but it's starting to pull apart the transactions that the counterparties have to do, and it becomes a horrific mess quite quickly. And again, to reiterate, this is the simplest version of a residential conveyancing transaction. So it's not a nuclear submarine by any stretch of the imagination, but it is still a complicated system that you're trying to replicate some of the properties of. And one of the simplifications, so I should say this was a proof of concept we did last year, and what some of the simplifications that we put in place to make the first version of the system were to only deal with one of the counterparties, banks, for example, instead of both banks when it comes to mortgage. And we didn't deal in massive detail with on-chain KYC and AML checks, although we've made some progress since on a variety of different ways to do that. And even then, you've ended up with a network model with sort of 5 different types of nodes, and it's not straightforward. So when it comes to experimenting it with these systems, I still feel like we're at the early stages. But reinventing the way some of this works does open opportunities. So in this particular work with the Land Registry, we looked at what's called an atomic transaction. So rather than having to wait for all the different states of the counterparties to sort of align sequentially or synchronously, you can start to think about title exchange in an asynchronous fashion. So the chain holds information, and once a set of certain conditions are met, rather than having to have all the counterparties work with each other to update their own understanding of the state in a kind of bilateral way, the system itself can do an atomic exchange where if certain states are met, the exchange of asset in this case goes ahead automatically. And so it's not a question of just replacing the incumbent system with a digital version of the same process. And part of this is about reinventing or re-evaluating which parts of the process are important and which might be improved upon. So that's sort of at a high level some of the things that we need to think about in terms of these systems. So not only how to disentangle very complex multi-stakeholder, multi-party contracts or contract chains of obligations, but also how we might alter the design of the system itself to make advantage of these new technologies coming in. And the first part of doing this from a sort of legal perspective is thinking about the incumbent contract. So the incumbent contract is a legal text, which most people on the call hopefully will be familiar with in some fashion, constructed out of natural language, i.e. the languages we use every day. And if we're thinking about how to instantiate that in the systems, we then have to start thinking more detail about a data model and sort of contract logic, the logic of the system. If we ignore for the time being May's observations that often you can code it incorrectly, that needs some work itself. And so I guess we've moved away from thinking about sort of machinery and architecture of the systems to focusing some of our own effort at Mishcons on thinking about the details of contract logic, sitting on top of the kind of DLT network of some description. And a piece of work that we started to do is try and figure out, where in this contracting stack are things best suited for these types of systems. And perhaps rather than thinking of the contract as a whole, just thinking about smart clauses as much as anything, right? If you're going to do lawyering in these second wave of smart systems, then you're most likely to start thinking about the structure of smart clauses themselves rather than the architecture of, for example, the distributed system. And so when you start thinking about clauses, there are a few things that the reason the contract is there in the first place, they're there to define what happens for breach or default of certain conditions. They're there to worry about warranties. And so thinking about the structure of a contract or a set of contracts, and again, I think the reason why real estate and construction are interesting sectors is because of the standardization of the contracting base fairly early on. So I think they're good places to start. And again, most of what we've, up until say the end of last year, most of what we'd worked on were systems around the happy path, so to speak, i.e. where all counterparties do exactly what they want. And so stuff that we've been working on this year has been thinking about not just rule ambiguity in contracting stacks, but event ambiguity. And we've done a little bit of work, which is, I guess, the next I'm going to talk about with the Law Society, thinking about how to think about data-dependent clauses. But just to pick up on May's point again about humans in the loop, there's a lot of human judgment in the way these contracts are structured at the moment, and the risk is mitigated in terms of reasonable efforts. And so again, there is a sort of piece of work to do to figure out, what percentage of clauses may or may not be open to smart clauses, or being put behind a measurement process that can inform the way the contract works versus having a human in the loop, or at least an arbitration process in the loop on how these systems will work. So this year we've done some work on kind of oracalized contracts. That's using DLT technologies as oracles or registers of data that you might want to build contracts off the top of. And we thought a little bit and done a bit of work around data schemas. In this case, in the context of COVID. So for example, leases that you might want to switch between fixed rental payments through to share of turnover based on whether or not you're allowed to trade. And we produced a white paper that's available from the CBT working paper series, looking at how to aggregate disparate sources of uncertain information, so that you can pull them together and then build a contract that has sort of meaningful terms for the clauses off the back of it. And so here we can see that this example that we made public is to do with pulling health data or trading data from various government websites, none of which necessarily talk to each other, and aggregating it in an Oracle on-chain so that counterparties could build contracts which ultimately depend on a state of the world in a way where the state of the world is itself tracked on chain. Again, we built stuff into kind of existing contracts, and in this case we're looking at a real estate contract, but we have similar examples for construction contracts, and we're at the early stages of figuring out which parts of a full contract, i.e. which clauses lend themselves commercially to becoming smart clauses, and then how parts of that contracting or parts of those clause systems can start to interact. So thinking about finding structure of clauses, thinking about finding the precedent within a corpus of contracts and cases, what are the most important clauses and where to start. And I guess the work we're doing at the moment is thinking, how do we identify, say we take a JCT contract over X period of time, how do we find the sets of clauses where they're commonly negotiated but divergent versus commonly they stick to the template, they're common but they're consistent, versus ones that are transaction specific. And so we're doing quite a lot of work on the natural language side of contract analysis. And the interesting thing is that in the last 18 months, the models for natural language processing have improved dramatically. I obviously won't go into the details here, but suffice to say that something that was very challenging 2 years ago and perhaps wouldn't have worked without an awful lot of effort is much more likely to be able to work off the shelf, or work with a higher degree of utility. So these are research benchmark data sets, and what you're seeing here is the increase in model performance from, say, late 2018, early 2019, through to early 2020. And the dotted lines here are human performance on these benchmarks. So for, these aren't industrial benchmarks, but in a research setting, you're getting human-like performance for a lot of natural language processing tasks. And that is a very different environment in which to operate in. So when I look at the sort of contract evolution or maturity here, this is from a publication sources at the bottom. Where have we managed to make sort of progress to date? Well, we have started to think in some detail about how the data gets into a contract and what, given the commercial clients we represent, what sets of data are important for the contracts that they use for facilitating their lines of business. And we have done a reasonable amount of work now on starting to extract or automatically extract obligations from previous contracts and trying to understand the differences between templated contracts and the ones that we have advised on or reworded based on particular details of a commercial relationship. So hopefully that set out a little bit of some of the stuff that we have been working on. And then in the last sort of few minutes, just want to say something about the state of the evolution of DLT systems themselves. So we've been doing a bit of work with computer science, and you heard earlier from Philip Treleaven at UCL. But here, this is a chronogram of all of the different chains, essentially, built up over the last 10 plus years. And you can see that it's a very bewildering array of different system properties, right? And trying to pick the right system at the outset for the type of contracting task you're interested in is a challenge. And it's a moving one. So one of the interesting things is thinking about the structure of consensus mechanisms. Like one of the significant innovations in these DLT systems is the notion of consensus, and at the moment is dominated by the use of electricity in sort of proof of work. And if we think about asset classes that are in hundreds of years, we don't necessarily want the energy overhead associated with maintaining them. So there's an awful lot of work going on in figuring out different consensus mechanisms, and I still think it's early when we consider the properties of systems that might be ideal for large scale construction or real estate deployments and applications at the kind of nation state level. And not only is the consensus mechanism developing, and I think it's probably one of the most interesting ones, but every aspect of it in terms of communities of practice and the operationalization of the technology is undergoing sort of continual change at the moment. So I think it's a good time to get started and start to be aware of the different properties that systems have. But I wouldn't worry too much that we haven't seen huge, large-scale deployments of these systems outside of, say, finance quite yet. Lastly, given that I work for and represent a law firm, Mishcon de Reya, there are all sorts of interesting ways that these types of systems interface with what I would slightly cheekily refer to as legal system one. And May pointed out a whole load of them to do with actually how you might, for example, enforce terms within a smart contract. And we just worked with Tech London advocates and the Law Society looking at a whole variety of different kind of legal considerations when it comes to the deployment of these systems. So if those are of interest to you, please go away and read that report in some detail, and also figuring out what is best conducted off-chain is a sort of key takeaway. There are things at the moment where on-chain causes sort of downstream issues, or more potential downstream issues, and so you need to start to tease these things apart. So summary of that is, I think it's still very early in thinking about these type of systems when it comes to technology. There's lots of work to do in trying to understand exactly how to apply it, and I guess the focus of our work at the moment is sort of a bit more empirical analysis of contracting clauses. But things that we are working on are interested in around real estate and construction are, for example, FBRI to do with tokenization of the asset classes, and standards being one that's mentioned frequently. So we're working with the Accord project, looking at trying to get kind of British Standard Institute kite mark for smart contract clauses. And if there's anyone listening who's interested in oracalized data structures or clause variations, happy to be contacted. Love to chat to you afterwards. Thank you very much.